Okay. Should we wait for someone or can we
Yeah,
go ahead?
let's give 2 more minutes. Amir is joining in, so
Yeah, sure.
Jonathan, you can go ahead and start.
Yeah. So someone is
Uh,
not joining.
Kim and Satya, you're able to join, right? You're able to see a screen?
Oh yeah, I can see.
Okay. Is the voice okay?
Hello. Is it okay?
So fine, yeah. I can hear.
Satya, is it good for you as well?
Yes, it's good for me.
Okay. Yes, Jonathan, please go ahead.
Yeah. Okay. So good evening, everyone. Good morning, who are in India. So what is the? I will go through what is Hadoop and how it works actually. So I'll introduce about myself. I'm Jonathan. I'm working from last 7 years, and with Hadoop I'm working from last 3.5 years. I have worked on almost all tools of Hadoop, so I'm using it in day-to-day activities. So Hadoop is a software framework for data-intensive computing applications. Uh, Satya and others, can both of you introduce in a one-liners so that I can go ahead? Hello.
Jonathan, can you just speak a bit louder?
Yeah. Okay. Yeah. Can you both of you introduce about yourself in one-liners? Hello.
Kim, let's start with you, Kim.
Can you hear me?
Can yes.
Yes, Amir, we can hear you.
Yeah, this is Amir.
Okay. Hi, Amir.
Hello.
Yeah.
The voice is reachable.
Why voice is not good?
Yeah, I
Is
mean like
voice?
it's kind of hard to hear.
Oh. Is it? Wait a moment. Is it now? Hello.
Yeah,
Hello.
yeah. I
Is
think
it
it's
okay now?
better. Yeah, it's better. May I know who's this?
Okay. Yeah. This is Janardhan. Amir.
Okay. Yeah, hi Janardhan.
Yeah. So I am the can you introduce about yourself? Yeah, Kim and Satya.
Kind of having a tough time hearing actually. Um,
Oh, still,
just give me a moment.
still, actually, it is highest sound in the microphone.
Yeah. Um, can you hear me?
Yeah. I can hear you guys. Pretty
Okay.
good.
Yeah. You may go ahead. I can hear it a little better now.
Okay.
So you were asking me something, I guess.
Yeah, I was asking like in one liner what you people are doing. If you can tell, then I can go ahead with the presentation.
I have finished my master's in computer science field, and I have done a project in my master's, and I have a good understanding of SQL and a little bit knowledge of Java.
Okay.
Yeah, so I've heard that SQL and Java are pretty much helpful for learning Hadoop.
Yes.
So I basically want to learn Hadoop, so I'm interested.
Okay. Yeah. Yeah. Thank you. Thank you, Ahmed.
No
Yeah.
problem.
Satya and Kim.
Hello. Yes.
Yeah.
Hello.
Yeah. Hello. Hello.
Yes. What was the question? I was unable to hear.
Can you introduce about yourself
Yeah.
in one line?
Bachelor's of Computer Science, and
Yeah.
I have also worked with Java very long back in like 2006 and 2007, and I took a SQL course recently, and I just had some break, and I'm back to work, and I'm looking for learning how to do.
Okay. Thank you. Yeah. I think Satya.
Yeah, this is Satya here, but
Satya.
I'm unable to hear you. Hello. Yes.
Oh. Okay. So Kim is left. Yeah.
I'm sorry. What is it?
Yeah. Okay. Okay. Can I go ahead?
Sure. Yeah,
Yeah.
that's it.
Yeah. Okay. So what is Hadoop? It's basically a platform for data analysis. So it's a software platform. So everybody is hearing Hadoop big data very frequently these days. What is that and why? So here is the answer. It's a software platform that lets you write programs that process vast amounts of data. So some of the frameworks within Hadoop are MapReduce for computational related things, and HDFS for file system. It's a file system, and Hive for warehousing, and HBase for online data access. It's a NoSQL database. So like that, we have n number of tools for every purpose. So Hadoop is nothing but it's a set of applications which run which uses distributed computing to run huge data in a efficient manner. So some of the properties of as of this. So Hadoop is a scalable. So what is scalability? So scalable means it can work for uh, any number of customers or at any number of data coming. So per se, today my business is running on 1 lakh for example, 1 million customers, and tomorrow business has grown and gone to 10 million. But still, there's no need to change at the software end. Just by adding a little more hardware, will be working fine. So that is a scalability. So scalability means whatever big may be your business go, my software should support that without any changes. So Hadoop is a scalable and it's economical. Why it is economical? In compared with the servers, the commodity hardware on which Hadoop works is very cheaper. So that's why our distributed computing on commodity hardware is very cheaper in compared to servers of same capacity. So it's efficient, it can run in a minimal time, so usually by 1/4 time or 1/3 time in compared with the servers because of the distributed computing. And it is reliable. We will discuss how it is reliable, but the basic principle of reliability is we can rely on Hadoop, so failure chances are very less. So it maintains multiple copies of data. So because of this reason, failure rate will be very less. Yeah. So this is what the Hadoop is, and we will get these benefits if we use Hadoop in our application or in our database. So if we see who are using Hadoop, so almost all the e-commerce companies and the social networking companies are using Hadoop along with the other big giants. So some of these are Yahoo, LinkedIn, Facebook, and Netflix uses Hadoop for their famous recommendation engine. So, and Google also uses Hadoop for their web indexing in another way. So if we go on telling, we have so many examples. So almost all the social and internet-based companies who are big, they are using Hadoop for analysis of their data, their users' data and advertisement data, right? So these are some of the other applications and sizes. So we will say it is NetSail is one of the companies which is using Amazon's cloud for Hadoop. So Hadoop is also offered as a service by so many cloud companies. So with with the help of Amazon EC2, so many companies are able to use Hadoop with minimal cost. So the core of Hadoop is MapReduce paradigm. So this is a differentiator factor between other parallel programming paradigms to Hadoop. So basically Hadoop gives you more control over the logic and less it has terms of writing or managing the all the resources. So if you just write a program, then everything else will be taken care by the framework. So per se, in a Java program, if I want to write multi-threaded application, so everything will be handled by the programmer itself. So which thread is using which resource that has to be handled by the programmer. So so many multi-threaded parallelized programming paradigms came. So So started with the parallel C++ to Java, .NET. So in every paradigm, they they didn't remove the resource sharing mechanism. So here in Hadoop, they have removed. That means for programmer there is no need to manage the resources. So resource allocation and management of the resource taken over by the framework itself automatically. So as a programmer, we will just write the program logic in two phases. So MapReduce paradigm works in this way. So since it is a distributed computing, I think everybody can understand what is distributed computing, right? So distributed computing works on basis of sharing of the work. So multiple systems share the work. So this is developed by the Google, and sort or merge based distributed computing. So sorting will happen in between one phase to other phase. So it is initially intended for searching or indexing application only, not just Google. Even in within Hadoop, it was intended for web indexing in the beginning, but later on this paradigm taken over in mainly data field. So basically data warehousing and etc. So it is basically a functional style of programming. So as we know, the famous functional language is Scala. So MapReduce paradigm works in the same style as functional programming. In mean it borrowed map phase and reduce phase from these. So map means it's a one-to-one mapping. So whatever input comes, we'll see that as a records and we'll operate that on basis of record level. And reduce means reducing the output to one or two, depending on the number of keys. So that many outputs. So these two terminology directly came from the functional style of programming. So if anybody knows Scala, you people can understand very easily this terminology. Yeah. So the next question comes how the MapReduce framework works. So this basically works as I told at two levels. One is the map and reduce. So it works on top of keys and values. So automatically keys and values will be detected from the input based on the input format by the mapper. So mapper will get the keys and values and it will output the keys and values. So what are these keys and values? For example, if we have a text and we have to write a simple count of number of words occurred. So each word how many times occurred in particular file. For say in a novel. So we got in text format that particular novel. So in this we can say input is every line of that particular file is a value and key will be line number. So my input is line number and the whole line of the data. So output would be key and value. It would be my the word occurred and what is the value. So might be every time is occurring, so 1 could be value. So first time occurred, if we can say that hello happened first time, so hello comma 1. So we can go on repeating whatever number of times comes hello comma 1. So this is a mechanism works on top of keys and values. So everything can be treated as keys and values. If key is provided, we can take the key. Otherwise, default keys will be there, like line numbers. So it works in the same manner. In the same manner, reduce operation also works. So how it is distributed, map reduce. So the processing of our Hadoop. So it works on top of input distributed in different places. So we will go through how exactly a particular file can be distributed across the cluster, across the machines. So this is the main funda behind the MapReduce. So two-level operations, everything works on key values. So this is a small example, just like we are using. So for example, if input line is this, Sai Baba is a god, am I. So it can be written in as output. So the basic input is complete line. So key could be line number and old value is value. Sai Baba is god, am I. So that can be treated and split it and report to the output of mapper like this, Sai Baba comma 1, and every word can be given it to the reducer as is, as it comes. Give it 1 so that we can count number of ones and get the exact count. So if we see next the how the reducer function could. So here just it's a addition, just a counting program for every word, whatever number of ways it can be. So how many times it occurred, that many times we can add it to the result. So in the result value part is 1 is repeated that many times. So if we add value parts, then we will get the answer how many times that particular word occurred. So we can see some more examples later. So I'm coming back to more details. We're going through HDFS. So basically, as I told, Hadoop has one file system called HDFS. Uh, so how this HDFS file system works. So it is a distributed file system, Hadoop distributed file system. It works on top of commodity hardware. So two of the main features of HDFS is it is distributed and it is fault tolerant by using the replication. So prior to HDFS, nobody has utilized the may nobody has make use of replication in the application. So what is the replication is having more than one copy of the same data within the cluster and make use of it whenever first one fails. So per se, in Hadoop by default we have replication factor of 3. So what does it mean? It means whenever data comes, it will be copied to 3 different places And if we are unable to access the first copy, we can go and get the second copy. If that also fails, we can go and get the third copy. So we are more fault tolerant than the other system. So it is entirely different from the backups. So backups won't be active at a time, but replications will be active always. So, for our applications, all the three copies of data is available at any point of time. Unlike backups, only one copy is available at a time, but replication means it is available to the application all the time. So by default it is 3. So that is available. All the three copies are available to the application. And second important thing is it is block oriented. What does it mean? So block oriented means when we are storing a big file in HDFS, it won't be storing as it is. So it will be stored as a blocks. So give me a moment. I will be using Blackboard. Sorry, board application. So for example, a file came and it is the HDFS. So it is basically works on the blocks. So whenever file comes, it will manage like blocks. So if it is two blocks of data is there, for example, it came as 200 MB file, then it will be treated in two blocks. So that is 128 MB one, and second one will be 72 MB. So these are the two blocks here. So it will be stored inside the cluster as a block 1 and block 2 and copied 3 times. So it can be B1 here and B2. So B1 copied twice if we have only two systems. So block 1, block 2, and here block 2, block 2 and block 1. So it could be like this. So if data comes 200 MB data, so I have copied like this. So it works in the same way. Whenever read request also comes. If it is read, then it will go to here and directly reads from here to here. So this particular thing could be, this is your client. So from client we are reading, means it will be reading from directly from here to here. So both the blocks will be read directly. So parallelly, by the time block 1 is read, block 2 also will be read. So the time consumption for processing or reading the data is very minimal in compared with the normal system. Okay. So this is how it will look like, whatever we have just seen. So if any client asks for the data, so it will go to a node called name node, and it will be stored in data nodes. Data will be stored in data nodes. So all the metadata will be stored in a node called name node. It is a controlling node, and in the data nodes, data will be stored block wise, and related info will be stored in name node. And whenever client comes with new data, it will be stored in the data nodes, and info will be shared with the name node. And if it comes with the read request, it will first hit the name node, and it will give you where exactly it is stored, and then it will go and fetch that particular record from the data nodes directly. So this is the how flow goes this way, and directly read. So if anybody has any doubts, people can type or speak to me about HDFS and MapReduce. So this is how any program in MapReduce works. So these are the main phases, and this is how it works. So as I told, it is a distributed processing system. So when our data comes, it will be distributed like this. We will split. This is called the splitting, and then the mapping will be done like this. Since we are doing the count program, so it will be distributed based on the lines. So here we have three words each. So then sorting should happen. So and then shuffling and reducing will happen. Sorting and shuffling, why it is required is to put all of the single words together. The output is not in order. So to get all of the particular words together, we need to sort them together and copy into one place. So like here, all the words should come here. So here sorted and copied here. Sorted the output, and cars will be sent here, wheres will be sent here, and days will be sent here, like that. So all the outputs of mappers will be sorted and copied to the respective places before reduce operation starts. And once the reduce operation starts, it will be counting based on the key. So our key here is a word. So for every word, this particular operation will run for the counting and we'll get the counts. So this will be the final output. So here we have splitting phase, mapping phase, sorting and shuffling phase, reducer phase, and finally we will get the result. So this is the overview of flow. So the first and foremost thing done in MapReduce program is it will be splitting the input while storing the data. So whenever it wants to run anything on it, it has to be working on each split. So per se, if I have 4 blocks of data, so processing should happen. So if processing need to happen, processing should happen on all the 4 blocks at a time. So uh, this is what enabler in Hadoop. So parallel processing. So this only saves a lot of time because by the time first block processing is over, we'll get all other blocks output. So one of the copies of the program is the master, and it will be copied to each and every system or node where the processing will happen. For example, ours is a Java program, then jar will be copied to all of them and independently working for that particular 64 or 120 MB piece of data. So the workers, that means the programs which are running independently, they will be assigned to that particular data, that is called split, and it works on the key value phase on the input data and passes each to the map function, and intermediate data will be there, and again that will be passed to the reduce function. So in between it will be in the memory, a third memory, and if data is very huge, it will be stored in locally, and finally output will come after the reduce happens. So here the main funda is how distributedly particular program is working. Typically it will be 128 MB now by default. So how our 120 MB chunks of files are working parallelly by in the mapper phase, and how it is again going to the reducer after sorting and shuffle happens. So in a nutshell, this is the overview of Hadoop. So applications are written in high level language. So there will be no sharing between the different systems, unlike normal parallel programming paradigms, where we have to wait for some resource, then we have to talk to each other about locking, unlocking the mechanism. And data is spread across the machines. And one more most important factor about the Hadoop is that it is a share nothing mechanism, and we are copying the code to machine where the data is available. For example, here if you want to process B1 data, okay, so here jar got copied, okay, and we are running data on this B1, okay. So, and the same way, here one more copy of program will be there, and we will be running on B2. So this is the major factor in Hadoop. So we are not copying data to the system where our Java program is there. We are copying the Java program to the system where data is available. So it will save a lot of network resource and time. So that's why Hadoop is faster than the other systems. So in a nutshell, this is the things happens. So data is loaded into the system, it will split into the blocks and map. Phase will work like this, and relatively smaller portions of the data. Master program allocates work to the node such that map tasks will work on the block of the data stored locally on that node. Just like we have seen, B1 is stored in that particular system. So only B1 data will be processed by the our mapper program from there. So B2 will be processed from the system 2. So like that, it is called data locality. So that is the small intro about how MapReduce file system and the processing system works. So HDFS and MapReduce works on top of distributed computing principles, and these are the some of the ecosystem. So in Hadoop ecosystem, everything works on top of HDFS and MapReduce. Okay, so the core of the Hadoop is only these two, HDFS and MapReduce, and on top of it, we have so many tools like Hive, Tick, and Scoop, Flume. These are some of the main tools. So mainly for data access from different systems and management tools. So like Zookeeper is a management tool, and EMR from Amazon is a management tool. So Woozy is a workflow engine. We can schedule anything. So like that, we can go and so on and so on. So around 100 different tools are there. Among these, we can cover around 6 tools which are very important. Those are Hive, Pig, Coop, Flume, and Woozy, and HBase here, along with the HDFS and MapReduce, which is the core of the Hadoop. So this is what Hadoop ecosystem is. So if we have to write a code, it will look like this. We have two different classes already defined. That is mapper and reducer. So mapper looks like this. So it will be extending the base, and mapper class will be there. We'll have keys and values, and we can implement whatever logic here. And in the same way, reducer will have reducer class, with keys and values, and we have a map method in which we will implement the logic. So here it is a map method, the mapper class. Here it is a reducer class. So it is the reducer class. Yeah. So that is the overview. So anybody can. I am open for the doubts right now. Yeah. Hello. Hello. Hello.
Yeah, I can hear you.
Yeah. Any doubts? Just finally, I will go through what we will cover and how much time it may take. So in this topic, whatever we have covered until now, if any doubts, you people can either type or ask the questions.
Okay.
People understood what Hadoop is and what it is meant for. Okay, if there are no doubts, I will just um, let you people know what we will cover as part of the Hadoop and how much time it may take and what are the prerequisites. Yeah. So Hadoop is simply data. Okay. So it is simply data warehousing technology for handling the huge data and processing. So what we need is, so DBMS concepts, how data will be coming and going, should know. And then any oops, oops basics. So, and what else we have? We don't need anything else other than this. If any Unix fundamentals, Unix commands, if you know, that is good. Otherwise, it is no issues. So that is how the basics will be covered on top of this. So what we will cover as part of the course, that is, we will first cover with the HDFS, and that is file system, and then we'll go with the installation of Hadoop. Then it will be map reduce. So map reduce frameworks. So it is basically a Java framework, and it supports three languages: Java, Scala, and Python. by native support, and it also supports C++ and shell script. It is a turnarounds are there for this. So MapReduce framework, to understand and program it will take um, around uh, 1 week time to 2 weeks, depending upon the person. So once we are familiar with MapReduce and HDFS, then we can go to the tools. These are the main tools. So Hive is for the data warehousing. So this is for the data warehousing. And then we have Pig, that is the ETL tool, just like Informatica and etc. And we have Scoop and Flume. These are the data ingestion tools, so getting the data from other systems. So once these tools are over, we can go to other tools, Oozy for scheduling, and once we can do end-to-end application using these tools, from the data ingestion to data exporting. Then we can go with the HBase, NoSQL database within Hadoop framework. Then we can go with the Zookeeper. So it's a management tool, the kind of maintenance or management tool. So apart from this, right now within Hadoop ecosystem, Spark is creating waves across the industry. So we can go through the Spark introduction, what is Spark and how it became very famous. So Spark is a in-memory solution for Hadoop related analytics solutions. So we will cover all these things in around time of 40 hours, depending upon the availability. So this is how we'll cover, along with we'll have kind of we have examples and questionnaire after every topic, and finally we'll have a project at the end of course. Yeah, so we'll cover these things. I will be mailing the people once this is done, what we do in the class. Yeah, I'm done. I'm open for the questions.
So when all will we be having classes?
So we will have classes on depending upon the availability of the time in the same in the morning times, evening times. So we can start as soon as possible. Yeah, Sadiq can answer this question better.
Okay.
I will plan schedule accordingly. Amir, I'll let you know.
Oh, okay. Yeah.
Janardhan, this training will cover both the administration and also development, right?
Yeah.
Satya, Kim, do you have any questions?
So
Could you
do you?
share the PowerPoint?
Sorry.
Please go ahead, Kim. What was that?
I mean, like, could you share the PowerPoint?
Yeah, sure. I will share.
Actually, I heard your voice, but I got some noise, so I cannot hear clearly.
Oh, sorry for that. Yeah, I will be sending the PowerPoint right after the class. Yeah, and this is just an introduction. So we'll go through each and every topic later in more details.
So will you be also covering Java separately, or how will be the coverage on Java or Scala?
Actually, covering programming language takes little time. It depends upon the few people and how many of you are familiar. So we can talk on this individually. We can take a call. So it shouldn't take much time. Even if we go through some of the basics of Java, we'll take a call on this. We'll talk to.
Actually, Satya, Amir and Kim have just completed the Java training. I believe they are good with that. Satya, if you want, I can share you the Java recordings that I have.
Yes, Sadiq, I have it actually, but I didn't go through it fully. So nothing much of Java will be covered in in the session, is what I understand.
We can do that. I mean, if other people are also interested, we can probably go over that.
Okay.
Amir, Kim, what's your say on that?
I didn't get you actually.
I mean,
So again,
do you
going.
also need yeah, again going to Java basics? Is it needed?
I don't think so. Good at I'm good at it actually. So
Okay.
only the last few topics, maybe like a few topics, maybe I will have to listen once more. But I don't think I have to go through all the full concepts on Java again.
Okay. Maybe we'll ask Janardhan to cover a few basic things that's needed.
Okay.
Okay.
Yeah, actually, I'm just uh, giving the pointers to what concepts. So basically, it's a OOPS concepts and IO will be there and serialization and collections. So these are the four areas we need to do from Java point of view. So for in that sake, even if you know like C++ collections, like data structures, then it will work fine. So serialization also same IO and OOPS. So in any programming language, if you know these concepts along with the basic constructs, so that will work fine. Our framework won't use many more advanced concepts. Okay, these are the four areas where we will be concentrating. So those who know already Java, they can refresh on these things, and people who don't know much Java, they can just if they want to refer some of the things, they can refer on these. Yeah, right.
Okay, Janardhan.
Yeah.
So we should be good for this session now. I mean, I'll let you know when is the next session starting. I'll send you a meeting invite to you all. Okay.
Yeah, okay.
Okay. Thanks everyone for joining. I'll talk to Jonathan offline. I'll let you know what the schedule. Please send me an email if you have any questions. Others, please. Hello. Kim, Satya, Amir, if you have any questions, just drop me an email. Okay.
Yeah, okay.
Thank you. Thanks for joining us.
Thank
Bye. Jonathan?